Okay, this will be the last video for this chapter. And in the previous video, I gave you this exercise. So we would like to calculate the probability that a tire is worn out before 32,000 and 37,000 miles. And how can you calculate this probability? First, write down that probability, right? And as I said, we are going to standardize x. But there are two inequalities around it. So we have to standardize all the related numbers, the numbers related to these inequalities to make the inequality still unchanged, right? So we have z in the middle, and 32,000 becomes minus zero point 0.6. So when you subtract 35,000 and divide by 5,000. On the other hand, 37,000 minus 35,000 divided by 5,000 becomes 0.4. By the way, of course, you may use a calculator, and you have to use calculator. I'm just showing you the result, just a sketch of the work. But of course, when you do your exercise, you may use a calculator, and if you use a calculator, I believe this algebra is not a problem at all. And then we obtained a probability expressed in terms of a standard normal distribution. That's what we wanted, right? That's what we needed. And after this transformation, the next step is to transform this probability about standard normal distribution, express it as cumulative probabilities of a small standard normal distribution. So you make it as a difference between two cumulative probabilities, right? Z smaller than 0.4 minus z smaller than minus 0.6. And then you are now ready to use Excel formula. Z probability smaller than 0.4 from Excel. If you calculate from Excel, then you will get this number. And if you calculate this probability and then from Excel, then you will get this number. Then just subtract them, and you are going to get 38.117%. That is the original probability we want you to calculate. Okay, so we learned three types of probabilities we can calculate using the standard normal distribution. First, you may calculate probability normal distribution smaller than something, and then standardization in the end takes this form. Also, you could calculate probability normal distribution greater than something, and then in the end, if you standardize and if you convert the probability into a cumulative probability, you will get 1 minus a cumulative probability of this form. So you may use this form. And finally, you could calculate probability between 2 points, A and B, and then again, you can calculate this probability by the difference of two cumulative probabilities about standard normal distribution. Okay, right? So there are only three types of probability forms. So I believe if you follow the steps, it should be straightforward, right? Okay, the next exercise we are going to consider is about percentiles. In many cases, actually, percentiles are more useful. For example, now suppose that you are the, say, advertisement manager of the tire company, and in an advertisement, you want to say this sentence, say 90% of your tires last longer than blah blah miles. How many miles can you put in here? And then you need to use the normal distribution idea, normal distribution, and calculate this number. So let me go step by step what we need to do. So suppose that we are looking for a number a such that the probability that a tire lasts longer than a miles is 90%, right? This is just a translation of this sentence. 90% of tires last longer than a miles. Then if you translate that into statistics notation, you will get this equation, right? So then what we are going to do is, so we are going to standardize in the first step, standardize x. So to do this, by the way, remember that the inequality is effective within this parenthesis. 90% is not related to this inequality. So inequality, you have to read it this way. Probability that x greater than a. So x greater than a, that phrase is finished within this parenthesis, and that probability equals 90%. So that means you are going to standardize only on this left-hand side. So I see many students are standardizing this guy, but actually that's not wrong. So this is probability outside like n, and the inequality ends within that parenthesis. So don't be confused. I'll show you with numerical examples. And so you standardize this probability, right? Left-hand side first. And then, on the other hand, 90% will work separately. So use Excel or a calculator to find a value that satisfies 90%, or top 10, or top 10%. So in a separate calculation, we are going to use the normal distribution formula to find this value that satisfies 90%. And then we are going to match the standardized probability to this value. I'll show you how to do that. So here, back to this example, let me show you the idea. So first, we are going to standardize probability that x, a tire, lasts longer than a number of miles. And standardization, as usual, goes like this: x minus mu over sigma, a minus b over sigma. And as I said, the inequality is valid within the parentheses. So that's it. So nothing else is affected by this standardization. A problem here is that you cannot calculate, because a is unknown, you cannot calculate this part. You cannot simplify this any further than this. So just keep this as it is. And then what we have is after standardization, you could say probability z, standard normal distribution, greater than this unknown part, equals 90%. And again, 90% has nothing to do with this inequality. Of course, it's probability, but inequality remains still unchanged even if you don't standardize it. So it's not a target of standardization. Standardization finishes within the parentheses. Keep that in mind. So this is the end of the first step. There is nothing more you can do here. And the second step, using the standard normal distribution, we did some exercises how to find this value. So from 90%, you find this value. That means you are looking for bottom 10%, excuse me. So you are looking for bottom 10%. So above the number is 90%, so below the number is 10%. So you are looking for 10 percentile, that is minus 1.28, right? So this is from Excel or a calculator. You need to find the relative value that satisfies 90%. And then from two separate procedures, we got these two probabilities, but they have the same structure, right? As you see, the standardization yields this equality, and Excel gives you this equality. And then what you need to do here is just match these two guys. These two equalities have the same structure, so these two components must equal to each other. So equate them, and then you can solve it for A. The unknown A in the end will be 28,600 miles. That is the answer. So, I colored it. So you are equating these two terms to have this. Okay, now it's your exercise. It's a little bit more tricky. Now consider, suppose that in a safety reference, you have to warn that drivers should not drive on a tire with too many mileages. So suppose that you want to say 95% of tires cannot last up to a number of miles, A miles. What is the appropriate number in this blank? And by the way, I will just give you some basic percentiles, right? Common percentiles are given like this. You may use these percentiles and you don't need to use Excel to find them. Okay, pause the video and try it by yourself. Okay, the first thing you have to set up here is to translate this sentence into statistical notation. That translation itself could be quite confusing or could be difficult, but once you see the answer, it sounds pretty obvious. So the probability that a tire mileage is less than A is 90%. That's exactly what it means. 90% of tires cannot last up to A. So mileage is smaller than A. That probability is 90%, 95%. That's this one. Once you set up this equality, then from here, it's mechanical, right? First step, standardization. Standardize within this parenthesis. So that you have probability z smaller than a minus 35,000 over 5,000. So it cannot be simplified anymore, and still it is 95%. This is the end of standardization. And in the second step, 95% from the clue of the probability, about the probability, you have to find this value. So 95% tires cannot last that point. That means it's top 5%. 95% is below, and there are only top 5%. So you may think it as top 5% value or 95 percentile. Either way, you can find, you can use Excel to find it, or I gave you top 5% is 1.64. That's what this means. Like, this means that only 5% cannot last 8 miles. So only top 5% tires can endure 1.64. That's how you can understand. And then 1.64 and this part are playing the same role in their respective equalities. So we can equate them, right? A minus 35,000 minus divide by 5,000 equals 1.64. So A is 43,200 miles. By the way, if you look at the form of A is expressed as the mean plus 1.64 is the standardized distance from the mean, right? It's the relative distance from the mean. That's the meaning of standardization. So 1.64 times standard deviation. So from the mean, the A is 1.64 above, right? So, and because the unit of this is standard deviation, you have to multiply 5,000. So 1.64 standard deviation above the mean is equivalent to this mile, right? So from the mean, you have to add 1.64 standard deviation. So you get this. Earlier, in the earlier previous example, also it's the same thing. We know that the answer, this tells you that the answer A must be 1.28 below the mean. 1.28 standard deviation below the mean. So A must be the mean 35,000 minus 1.28 standard deviation. So standard deviation 5,000, then you get this number. So they have, so this standardization is a relative distance in terms of standard deviation. So if you invert the standardization process, you will get mean, and then like from the mean you add or subtract a certain relative distance times the standard deviation. That's a typical form of A, and we are going to use similar format later on. Okay, so we learned how to handle this kind of problem. When probability is given, we would like to find the value A for possibly non-standard normal distribution. So when X is non-standard, what is A for a certain probability? Then the idea is to standardize A and X, of course, standardize within the probability, and then also use the probability to find the corresponding corresponding value that provides the same structure of the probability, and then equate this guy to this guy and solve it for A. Then you will obtain mean plus the standardized B times standard deviation. B is the relative distance from the mean, right? So connect these steps to the numerical example and see how they work. And you will do more practice in the homework. Okay, final summary. This is what we like. This chapter is more like a preliminary chapter for what we are going to do in the future. And whenever you need to calculate a probability, you are going to use these techniques. So we need to learn 4 different types of calculations, form of probabilities, and you need to know how to calculate them. One is cumulative probability smaller than something, and then the other is probability greater than something. You have to transform this into cumulative probability. And then another form is probability in between 2 points. And then finally, maybe most difficult part is to compute percentiles or top certain probability values. So, and you may apply these calculations to non-standard normal distribution. So it requires an additional standardization step, but that shouldn't be a problem. So as long as you know how to handle standard normal distribution, it shouldn't be a big problem. Okay, this is the end of the chapter. Excuse me. Yeah, so chapter 6 is over. And again, I said we are going to use these results for later chapters. So I want you to do enough exercise in this chapter. Okay, thank you for watching, and see you next week.